Okay guys, so what we want to do is finish our notes from Tuesday. So on Tuesday we were drawing box and whisker plots, and we had that set of data that was the chart with the amount of sugar in each cereal. So to construct our box and whisker plot, we first put all of our data in order, and then we cut it in half. So we identified the lower half and the upper half. But because box and whisker plots each represent 25% of the data, we needed to find the first quartile and the third quartile. So the first quartile is at the quarter mark, which is half of the lower half. So we found quartile 1. Because it fell between 4 and 5, our first quartile was 4.5. And then we did the same thing to find Q3, which is halfway into the upper half. So in this case, it was between 10 and 11, so it would be 10.5. Our minimum is 1, our maximum is 22, and then our median is right in the middle of the upper half and the lower half, so in between 7 and 7. So in this case, our median is 7. So we have our min, our Q1, our median, our Q3, and our max, which is our 5-number summary. So we're going to use that 5-number summary to construct a box and whisker plot. So on our to draw our box and whisker plot, you have your number line, and remember each vertical line represents one data point. So we're going to number these 1 through 22. Okay, so we number our number line 1 through 22 because our minimum is 1 and our maximum is 22. And we start with drawing our box right in the middle. So the lower half of our box starts at Q1 and ends at Q3. So we're going to draw our box starting at 4.5. So draw your first line at 4.5. And it's going to go all the way to our Q3, which is 10.5. So it's going to go to right here. So you're going to draw your box from 4.5 to 10.5. So there's our box. Now our whiskers are made from the minimum and the maximum. So our minimum's at 1 right here, and then we connect that to our box. And our maximum is at 22, and then we draw a whisker connecting that to our box. And then the only thing we have left to do is to identify the median, which in this case is 7. So we draw a line in the box at 7. So if you notice, our box and whisker plot has 4 kind of quadrants. Our first one right here, which goes from the minimum to Q1, which is 4.5. It has this middle one right here that goes from 4.5 to 7, which is our median. From our median 7 to 10.5, that is our Q3. And from 10.5 to 22, which is our max. So this would be our box and whisker plot. So each one of these quadrants represents 25% of the data, the box representing the middle 50. So if we look at our box and whisker plot, most of our data is concentrated on the left because our whisker is really long and goes to 22. So just like we found in our dot plot, we would call this skewed right. Because there is more data on the left-hand side, so there is less data on the right. And if it's skewed right, that means that 25, 50, 75% of our data have, this is at 10.5, so we can say have 10 grams of sugar or less per serving. Because 75% of our data, 3 of our 4 quadrants, is on the left-hand side, so they have less amount of sugar. So that's constructing a box and whisker plot, which should be reviewed from 7th grade. We are going to look at a new kind of plot now for 8.1b. So set up your notes for 8.1b. (8.1b), we are going to represent data on what we call a histogram. So here's some definitions for you. A histogram is a graphical way to display quantitative data using vertical bars. So it looks more like a bar graph. Each of the bars on the histogram is called a bin, and the bin refers to the width of a bar on a histogram, and it represents an interval of data. So we can write out each interval of each bin as an inequality. So it does not show individual data values. It shows intervals of data. The frequency is the height of each bar, which means the number of data values included in any given bin. Histograms represent continuous data, which is data that can take any numerical value within a range. So when you see this, you'll see bars, and within a certain range or interval of measure, and any of the values included in there could be within that interval of measure. So we call that continuous data. So here's an example of a histogram. So on this histogram, it's measuring the amount of hours spent playing video games on the weekends by a number of students. And the way that we read this, the numbers are given within every half hour. So this first bar along the x-axis is labeled the number of hours. So from 0 to, it stops at 5, but it doesn't actually reach 5, so we would say 4.5 hours being played. The height of the bar tells you how many students. So it goes up to 2. So there are 2 students that play between 0 and 5 hours on the weekends of video games. The next bar measures how many students that play from 5 to 9.5, and in this case it goes up to 3. So there are 3 students that play between 5 and 10 hours. The next bar, or the next interval, is 10 to 15, so it's actually 14.5 because it doesn't actually touch 15. And there are 4 students that play that many. From 15 to 20 hours, it goes up 7, so there are 7 students. And from 20 to 25, it goes up 9. So the width of the bar, or the bin, tells us what the interval that we're looking at. So in this case, it's 5 hours of video game playing, 0 to 5, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. The frequency, or the height of each bar, tells us how many students fall within that category. So we're going to answer some questions about this particular histogram. The first question is, how many students play less than 5 hours of video games? So we look at our 5. Now the left-hand side of the bar is the minimum of your interval. So we're looking at those that play less than 5, so that fall within the 0 to 5 bin. So that's talking about this leftmost bar, and there are 2, it goes up to 2. So there are 2 students that play less than 5 hours. So my next question is, how many students play at least at least 20 hours of video games. So that means 20 hours or more. So that would actually be this bar, the furthest right one, because 20 is the minimum, 25 is the max. So from 20 to 25, there are 9 students that play at least 20 hours of video games. The next question wants us to represent the bin that contains 15 as an inequality. So they want us to write an inequality that represents the bin that contains 15 as part of it. So we have to define a variable first. I'm going to let our variable be h, which represents the number of hours. And then let's go back and look at our histogram. So remember, our histogram goes to the nearest half hour. So this bin, the third one that goes starts at 10, actually goes from 10 to 14.5. So it does not include 15 at all. So we're going to actually be looking at the fourth bin, the one that goes from 15 to 19.5. 15 is the smallest amount. 20 is where the next bin starts, but we're not including 20 in this bin. It's included in the next one. So the way that we would write this inequality, 15 is our minimum, and it is the least amount, or we could be equal to 15 because it is at least 15. So our number of hours is definitely greater than or equal to 15. But the interval also includes up to 20. So we can't actually include 20 because it's part of the the next bin, but we know that we are less than 20. So 15 is less than or equal to h, which is less than 20. The next question wants to know how many students play 5 to 9.5 hours of video games. So we go back to our histogram. So 5 to 9.5 is this second bin right here, and there are 3 students. So we would say 3 students. Question E wants to know how many students play 22 hours of video games. So if we look at our histogram, 22 hours falls between 20 and 25, and there are 9 students that play 20 to 25 hours. However, any of these 9 students could be playing anywhere between 20 and 25 hours. We don't know the exact amount of hours each individual student is playing, because our histogram only shows us how many students are playing within that interval. So on a histogram, you can't determine exact hours that students are playing. So we would say you can't determine exact hours of playing because the data could contain any value from 20 to, it goes to 25, but remember this is half hour, so 24.5 hours. So a histogram only shows us how many students fall within the interval. It never shows us exact amounts. The last question about our histogram wants to know how many students total were included. So if we look at our number of students total, that played 0 to 4.5 hours, there were 2 students. From 5 to 4.5, there were 3 students. From 10 to 14.5 are 4 students. The next one contains 7 students, and the last one contains 9 students. So all we have to do is add up all of those students together. So if we add up 2 plus 3 from the second bar, plus 4, plus 7, plus 9, we get 25 total students. So that's how to read a histogram. Now we actually want to make one. So I'm going to give you some data, and we're actually going to draw our own histogram based on the data. The scores on a math test are 70, 93, 83, 55, 88, 99, 58, 73, 80, 75, 93, 95, 85, 95, 73, 65, 83, 82, and 90. And we're going to construct a histogram based on those scores. And our first interval is going to be 50 less than or equal to x less than 60 as our first interval. So our first step that we're going to do is we want to put the data in order. So I'm going to have you pause the video and put all of this data in order. So in order, you should have got 55, 58, 65, 70, 73, 73 again, 75, then 80, 82, 83, 83, 85, 88, and then I'm going to run out of room. So 90, 93, 93, 95, 99. After we put everything in order, because if you notice our first interval, they want us to use 50 to 60. So we're going to be doing intervals in terms of tens. So we want to group each of the data in terms of the tens place. So we're going to group first the 50s, and then the 60. There's only one. We have 70s, 80s, and then the 90s. So to construct our histogram, we're going to first draw an x and y axis. The largest amount of students that we ever have looks like the 80s group, and there's 1, 2, 3, 4, 5, 6 of them. So I'm going to have my y-axis go up to 7. And then we're going from 50s, 60s, 70s, 80s, 90s. So my 0 is going to start here at 50. 2, 3, 4, 7. So label your y. So my first one is going to be from 50 to 60, which means my next interval is going to be from 60 to 70, 70 to 80, 80 to 90, and then finally 90 to 100. So let's label our histogram. The x-axis is going to be our test scores, and the y-axis is going to be the number of students. So then the frequency of each bin is going to be from however many students that score within that range. So our first range from 50 to 60 has 2 students. So I'm going to draw my bar between 50 and 60 up to 2. You can color it in if you want. My second one, 60 to 70, has only 1 student, so I'm only going to have it go up 1 bar, or 1 space, and then color that in. From 70 to 80, I have 1, 2, 3, 4, so that's going to go up to 4. From 80 to 90, we have 1, 2, 3, 4, 5, 6. So that's going to go up to 6. Color it in. And then from 90 to 100, we have 1, 2, 3, 4, 5 students. So that's going to go to 5. And then color that in. And that's our histogram. So that's how to read a histogram. If you notice, most of our data is definitely off to the right-hand side, so that means we are skewed left on this. So that means most students scored between a 70 and a 100%. According to our histogram.